going to talk about building polynomial functions today, and before we get there, we need to digress a little bit and go back to some older material, try to get that back in our minds a little bit, and then we can relate it to our new work today. And the first problem that we're going to do, it says write the following cubic polynomial equation in its factored form by grouping. So we give it away because we tell you even what method to use, which I wish that we wouldn't have done, but anyway, we did. So if you remember from factoring by grouping, what we're going to do is we're going to take the first two terms and group them together, and the last two terms, and we're going to group them together, and we're going to factor. So we look for our greatest common factor in the first group, which is x squared, smallest exponent, and then we had 3 x's, we took out 2, so we have 1 left. We had 2 x's, we took them both out, so we just have our coefficient of 2. In our second group, what's the greatest common factor between 9x and 18? 9. And in fact, we're going to be minus 9. And if we've done things right, we better end up with x plus 2 in this parentheses. Negative 9x divided by negative 9 is x. Negative 18 divided by negative 9 is positive 2. And sure enough, we're good here. And what we see in each group is an x plus 2. So we're going to factor out an x plus 2. And then we also have an x squared minus 9. If we take a closer look at that, we factored by grouping. Can we do anything else to that problem? Not yet. I mean, that's part B, and we're going to have to do that. But could we factor any more? Yes. What can we do? The x squared minus 9. If you don't have enough room, I'm going to squeeze it in over here in B. If you don't have enough room in your problem, or in your space, we have x plus 2, but x squared minus 9 can be factored as well. Remember what we do. It's the difference between two squares. X squared is x times x, and 9 is 3 times 3. Difference between two squares, different signs. And now we can take what Jessica said, which is part B. State the zeros of this cubic function. We're going to set each of these factors equal to 0. Because we want to know what they are. Where does the graph cross the x-axis? So we take x plus 2, and we set it equal to 0. We take x minus 3, and we set it equal to 0. We take x plus 3 and set it equal to 0. And by the way, some of you don't need to show that step. Some of you can say, oh, x equals negative 2, x equals positive 3, x equals negative 3. That's fine, but I do want to show where that's coming from. There's the x equals negative 2. If we add 3 to both sides, here's our x equals 3. And we can subtract 3 from both sides, and we get x equals negative 3. I hope you don't have to show the work, but if you do, there it is. So next here, what we want to do is we want to know, well, what's the end behavior of this polynomial? And the thing is, if you know the sign of the leading coefficient, we can identify what the end behavior is. So what's the sign of the leading coefficient? Well, in front of the x cubed, there's nothing, so it's a positive. So positive leading coefficient means that this value is going to be a positive here. So the question then is well, as x goes to negative infinity, what's happening? And if you can't tell, you're going, well, what's she talking about? Then graph it. And by the way, I have a lot of functions in my calculator right now, and I'm not taking them out. So I hope that I'm in the right space here on there, and I am. So none of the others are going to graph. But if we type this in, and it doesn't matter which one we type in. We can type in x cubed, the original, plus 2x squared, minus 9x, minus 18. And we look at our picture. Well, what's our end behavior here? As we go to the left on our graph, as x goes towards negative infinity, what's happening is that our graph is going in the downward direction. So x is going to negative infinity. And as we check there, as x goes to positive infinity, which is going towards the right on the graph, and we go this direction towards the right, our graph seems to be going in the upward direction, which means that we're going to positive infinity. So there is our end behavior. And finally it says, find the y-intercept of this cubic polynomial. Well, for those of you who are going to be taking college algebra next year, we talk a lot about, in college algebra, about what's the x-intercept, what's the y-intercept. So I want to show you again how to find this algebraically. And what we do to find the y-intercept is we let x equal 0. So let's go back into the original equation, although it doesn't matter if we go back into the factored form or the original. And we're going to get 0 cubed plus 2 times 0 squared minus 9 times 0 minus 18. What's 0 cubed? 0. What's 2 times 0 squared? 0. What's 9 times 0? 0. What's our y-intercept? Just the negative 18. The first three terms cancel out. So negative 18 is our y-intercept. If we want to get really technical, it's 0, negative 18. That's our y-intercept. Hopefully, at least that looks familiar to you. That is something that we have worked on this year. Late last year in December as well. But now what we're going to do is we're going to go the other direction. On that first problem, we were given the equation and we found the roots, and then we answered some questions about the polynomial. In example number 1 here, we're given the picture, and it says, use the information from the graph to write a possible function rule for f of x. Express the equation in equivalent factored form, as well as in standard form, and then you can type this in your calculator to check. So when we start with this, it says state the x-intercepts of the function, and I'm going to write a little bit above this line. But what's one of the x-intercepts of this function? Negative 3. I'm going to write it above that line. X equals negative 1, negative 3, negative 1, negative 3. Our other value is going to be x equals 1. So there's our roots. We had to find them in the previous question. But what's going to happen here to state the factors is we're going to add 3 to both sides. And when we add 3 to both sides, we're going to get the factor x plus 3. We can do the same thing to our other root of 1. We can subtract 1 from both sides, and we get x minus 1. So if we state the roots, and then we move them over so that they're with the variable, we've got this in factored form. Well, there's the factored form. What we need to do to finish here is we need to find the standard form. So in order to do that, we are going to FOIL or use distributive property on this x plus 3 times x minus 1. So I'm going to run out of room a little bit here, but I think we'll be okay, and even you can write underneath the line. There's enough space. But if we multiply this, x times x is x squared. X times negative 1 is negative 1x. No, you don't have to write the 1, but sometimes it's out of sight, out of mind. 3 times x, and then 3 times negative 1 is negative 3. First, outer, inner, last, if you like the FOIL method. So when we finish, and again, you might have to write underneath this line, standard form is y equals x squared. We have like terms here, negative 1x plus 3x is plus 2x minus 3. And if you compare to what we started with in the review section, we started with an equation like that, and we ended up with the roots. Here, we started with the picture, and we ended up with the equation. So on example number 2, we are already in factored form. In our equation, that's nice. It says state the zeros of this function. So again, there's some of you that can do that right away, and some of us, we need to show more work. We're going to take negative x and set it equal to 0. We're going to take x minus 3 and set it equal to 0. We're going to take 2x plus 5 and we set it equal to 0. Well, when we divide both sides by negative 1, we get x equals 0. When we add 3 to both sides, we get x equals 3. And over here, when we subtract 5 from both sides, we get 2x equals negative 5. And divide both sides by 2. So I ran out of a little bit of space there, but x equals negative 5 halves. There's our zeros, which I frequently call roots. Zeros or roots are where the graph crosses the x-axis. They're x-intercepts. Part B says that we want to write the equation in standard form. Well, to write the equation in standard form, what we're going to do is we're going to multiply this together. And when we do, what I'm going to recommend is that you FOIL the two binomials together first, and then multiply by negative x in the end. It's not the only way to do the problem, but sometimes people make a mistake because they think that that negative x needs to be distributed to the first parentheses and the second parentheses. And once you distribute it once, you don't distribute it twice. So again, what we're going to do is we're going to take negative x times x minus 3 times 2x plus 5. And what I'm saying here is I recommend that we multiply these two together first, get an answer, and then multiply by the negative x to finish. I am going to have to infringe in question D in terms of space. But when we FOIL here, we're going to get 2x squared plus 5x. Negative 3 times 2x is minus 6x. And negative 3 times positive 5 is negative 15. First, outer, inner, last. We distributed the x and then we distributed the negative 3. When we combine like terms, here we get 2x squared minus 1x minus 15. And once again then, I'm going to multiply by negative x. And if you have to infringe on space here in part D, we only need about that much space for question D. So if you have to move into that space in question D, it'll be okay. So now what we're going to do is we're going to take negative x and we're going to distribute it over all three of those. And we end up then with negative 2x cubed. Negative x times negative x. Negative times negative is positive. And negative x times negative 15 is positive 15x. And there's our standard form. Well, now that we've got our standard form, how do we classify this polynomial according to its degree? It is cubic. Our highest value is 3. And what is the maximum number of turning points a cubic polynomial can have? 2. 1 less than our degree. Now, it says, what is the end behavior of this function? And once again, notice that our leading coefficient is negative, which means that when we get down here, we're going to finish by going negative. But again, if you're thinking, what is she talking about? If you don't know, then go to the calculator here. And again, sorry for all the stuff that's in here, but I need it for another class. And let's type in our function. And I'll type in the original, which was negative x times x minus 3 times 2x plus 5. And when we look at the picture here, once again, as x goes left on the graph, so as x goes towards negative infinity, it looks like our graph is going in the upward direction. So y is going to positive infinity. We've already determined that as x goes to positive infinity, to the right on the graph, and our graph is going in the downward direction, which is going towards negative infinity. And finally, what causes something to, let's see, how could you have predicted the end behavior before putting the equation in standard form? The leading coefficient. Look at the leading coefficient. It's all contingent on whether it's positive or whether it's negative. But if that's confusing to you, don't overlook the fact that you have a calculator that will show you or help you with what you need. So problem number 3, another picture. The graph at the right is a quartic polynomial. What does quartic mean? 4 means there's 4 to the 4th power. So it says use this information from the graph to write a possible rule for c of x. Express this rule in factored form and standard form. So start a little bit left on your paper. The first thing that I said is, well, what are some of our roots here? What's one of them? -2. There's a root. Another one? Looks like 0. And it looks like we have one more. Over here at 3. So once we've got that, and I didn't do very well on my space here, but what we can do is we can add 2 to both sides. Add 2 to both sides. And when we add 2 to both sides, that's going to give us our factored form here, which is going to be x plus 2. We can add or subtract 0 to both sides, but we get x plus 0 or x minus 0. And do we really need to write the 0? We don't. And here, if we subtract the 3 from both sides, we get our third factored value. And let's rewrite this a little bit better. We don't need to write 0, x minus 0. We're taking nothing away from x. Let's put that out here in front. And then we have x plus 2 and x minus 3. I wrote the x out in front because it's a single value. And once again, what I can recommend here, because there's the factored form, when we multiply this, I recommend that we multiply these two together, get an answer, and then multiply the end value. However, there's one more issue in this problem. Do you see it? And it's a hard one to see for the first time. But at -2, we cross. So when we cross, this graph looks like a line. So what would our exponent be on our x plus 2? It's actually going to be a 1, because it looks like a line. At 0, we touch, and it looks like a U-shaped curve. What does that exponent have to be on the value where we get the 0 for the root of the function? It has to be 2. Here's a quadratic. I'll draw it in so people can see it on the video. There's the U-shaped curve. So we're going to get a 2 right there. And then finally over here at 3, it looks like a line. So that one's also going to be a 1. Now we still need to multiply the two binomials together first. But we needed to recognize the multiplicity within this problem. So we multiply. We get x squared minus 3x plus 2x minus 6. X times x. X times -3. 2 times x. 2 times -3. If we combine like terms, then we end up with x squared minus 1x, and no, you don't have to write the 1, minus 6. But don't forget that we haven't dealt with that x squared. So we multiplied the two binomials together. We're going to finish, and it's okay if it extends down in here into this bottom value here, into part B. X squared times x squared is x to the 4th. X squared times negative x is negative x cubed. We had 2 x's, and then one more is the 3. X squared times -6 is negative 6x squared. And if we want to get technical, it's y equals, and actually it's c of x equals is what we have. Equals x. But what do we notice about our end behavior up here in our graph? Well, what we notice is that to the left, y is going towards negative infinity, and to the right, y is going towards negative infinity. What has to change over here in our equation? The coefficient, the leading coefficient. You couldn't hear her, but she said it. And in fact, what happens is that this entire value here would have to be negative. So when we finish here, so let's see, to make a better fit, use your knowledge of end behavior to adjust the equation. So when we finish this, we're going to end up with negative x to the 4th. And then we're going to end up with positive x cubed. Negative times negative is positive. And then Negative times negative is positive again. 6x squared. So we need to be careful with that end behavior, because that can tell us a lot about our graph. So finally here, to finish, and hopefully I'm not going too fast, but finally, to finish, in this last example, we're just given some roots. F of 2/3 equals 0, f of -5 equals 0, and so forth. These roots are in function notation, which sometimes is confusing to people. But all we have to do is this. We need to know what that means. And as I look back here, what this means is x equals 2/3. It's called a zero of the function because the y value is always 0. But f of 2/3 equals 0 is the same thing as x equals 2/3. F of -5 equals 0 is x equals -5. F of +5 equals 0 means x is +5. And f of 4 equals 0 means the same thing as x equals 4. So if we put these back in factored form, remember what we have to do. We can subtract 2/3 from both sides. And we get x minus 2/3. We can add 5 to both sides. And we get x plus 5. We can subtract 5 from both sides. And we get x minus 5. And finally, we can subtract 4 from both sides. And we get x minus 4. Well, sometimes that fraction is confusing to people. But there's a method that we used to teach in Algebra 2 in terms of factoring, which was called slide, divide, bottoms up. Now, we don't need to know how to do that. But what I do want to show you is this bottoms up concept. Because this is a fraction, and sometimes people don't like fractions at all, what we can do is we can do bottoms up. We can take this 3 and we can move it up. So x minus 2/3 is the same thing as 3x minus 2. We move the 3 from the bottom up to the top. Now the other values don't change. We still have the x plus 5. And we have the x minus 5. And the x minus 4. But one particular interesting idea in this problem here is we have x plus 5 and x minus 5. Do you know what x plus 5 and x minus 5 are called? Well, you might not remember the word, which is conjugates. They're a conjugate. So they don't completely cancel out, so be careful with that. Jessica? They don't cancel each other out. But let's multiply together the x plus 5 and the x minus 5 together. Then let's multiply the 3x minus 2 and the x minus 4, the other two values together. And then to finish, so we have it in standard form, we'll multiply our answers from our red problem and our black problem together. So a couple people said cancels out. Well, something cancels out. We get x squared minus 5x plus 5x minus 25. And what happens here is, even though the whole value doesn't cancel out, the 5x's, one's negative, one's positive, they cancel out. So what we're left here with the red polynomial, which I just started writing in black, the red polynomial is x squared minus 25. Well, over here with the black polynomial, we're going to do the same kind of multiplication. We get 3x squared minus 12x minus 2x plus 8. First, outer, inner, last. When we combine like terms, we end up with 3x squared minus 14x plus 8. And now we're going to multiply our red polynomial and our black polynomial together. When we do this, and this seemed to cause some trouble, we're going to take x squared. We're going to multiply it by this term, and this term. And then we're going to take the negative 25, and we're going to multiply it by this term, and by this term. That's going to put us in standard form. We're going to have to combine some like terms, but x squared times 3x squared is 3x to the 4th. X squared times negative 14x is negative 14x cubed. X squared times 8, both of them positive, gives us positive 8x squared. So we multiplied x squared by all three of the values in that black polynomial. We're going to do the same thing with the negative 25. Negative 25 times 3x squared is negative 75x squared. Negative 25 times negative 14x is 350x. Negative times negative is positive. And negative 25 times 8 is negative 200. So when we go back and look, there's not actually very much of like terms here. We've got this and this. So our standard form is 3x to the 4th minus 14x cubed minus 67x squared plus 350x minus 200. What's our degree of this function? Four, 3, 2, 1, 0. It's 4. What's our maximum number of turning points? 3. 1 less than the degree.